Yeah, it's great to be here today. I think this is like, it's a crazy moment in the world right now, but it's also a really exciting time to be in cloud because I think there's a lot of cool stuff happening. It's a fun time to be a developer with all the stuff that's going on with AWS and with all these other great companies. And one of the services that I really love and I'm here to talk about today is Amazon DynamoDB. This is a database provided by Amazon AWS, a NoSQL database that's pretty interesting, and a few interesting things that I really like about it. Number one, you're going to get consistent performance at any scale. So this was built for really huge scale stuff. This was basically built, a version of this was built internally for Amazon.com for some of their retail scaling challenges. And now a lot of huge customers like, Amazon.com, Lyft, Uber, Samsung use DynamoDB because you're going to get consistent performance as it scales basically to any size. Another thing that's really great about DynamoDB is its flexible billing model. So, traditionally with a database, you're going to be, paying for CPU or for RAM. But with something like DynamoDB, you actually pay for the reads and writes themselves, which is pretty amazing. And actually, you don't even have to pre-provision some of that if you want to. So you can use an on-demand billing mode where you're going to pay for the read and the write directly, which is pretty awesome. And then the reason I got into DynamoDB, it's very serverless friendly. It works well in a serverless environment. It works well with infrastructure as code. It works well with the Lambda connection model. It feels like using any other service in Amazon. So that's just a preview of why I like DynamoDB. But this talk is going to be about DynamoDB best practices. I think it'll be probably about 35 minutes, and then I'll hang around for questions on anything we covered here or any other DynamoDB questions you have as well. So feel free to ask questions and queue those up as you need them. In terms of what we're going to cover today, first off, I just want to start off with some DynamoDB terms and concepts. Just get us on the same page with vocabulary, terms, concepts, and understand what that looks like. Second section is what I call SQL versus NoSQL. So I'm guessing a lot of you have a relational background, a lot of experience with using SQL. And we'll talk about, what's different in DynamoDB, what sort of features they've removed from SQL or things you need to change about that. And then what are the implications of that as part of your data modeling and your process there. Third thing we're going to talk about is this really important concept called item collections and how that interacts with the query operation, which I think is pretty foundational to learning more advanced stuff in DynamoDB if you're going to use it for more than just a key value store. And then finally, we'll get into sort of the fun part, which is looking at actual, some common patterns. So, there's some common patterns that arise in all applications. No matter what type of database we're using, I'll show how to do them in DynamoDB. Who am I? I'm Alex DeBrie. I wrote the DynamoDB book. This was about 2 months ago. I released this one. About 2.5 years ago, I created DynamoDBGuide.com, which is just a free resource. I had watched Rick Houlihan's talks at reInvent and wanted to understand how Dynamo works. So I made that site. So check that out. I'm an AWS Data Hero and just a general AWS fan, a serverless fan in general. If you want to know more about the book, you can get it at DynamoDBBook.com. I think it's the most comprehensive guide to data modeling with DynamoDB. It's 450 pages, lots of extras, lots of different strategies, and then a lot of examples as well. I see some people asking about discounts on the book. I can set up something like that. So remind me, I'll set up a code or something like that, and we can get something figured out there. Cool. So, oops. All right. So let's get started with DynamoDB terms and concepts. Just to get us on the same page, there are 4 key vocabulary terms I want to talk through here, and they are table, item, primary key, and attribute. We'll walk through this by way of an example, and I'm just going to show you sort of some users. So imagine your application, users sign up, they have a username, first name, email, all that stuff. We'll use that as an example to show some of these concepts. So first of all, here's our table. We have 4 different users in it. We have myself, Alex DeBrie, and we have a bunch of folks associated with Amazon, like Jeff Bezos, Jeff Barr, CTO Werner Vogels, things like that. All this data together, that's going to be called a table. So it's going to be similar in some ways to a table in a relational database. It's going to be different in some ways too, we'll get to later on. But basically, a collection of all that data is your table. Also similar to like a collection in MongoDB, if you're more familiar with Mongo. Second concept I want to talk about there is an individual item. So if you're looking at a particular record, that's going to be called an item. And that's going to be comparable to a row in a relational database or a document in something like DynamoDB. A bunch of different attributes that are all together. Now, when you create your table, you need to specify a primary key, and every item in your table needs to have that primary key. And that's what we have here on this table. We're using a primary key of username, and every item in our table will have that. It also must uniquely identify each item in that table. So you can't have two items that have the exact same primary key. They would just override each other if you tried to do that. Now, in addition to that primary key, we have these other attributes over here, like first name, last name, email. You can attach sort of any freeform attributes that you want onto DynamoDB items. So you don't need to specify these attributes up front when you're creating a table. So it's comparable in some ways to columns in a relational database, other than, in a relational database, you need to declare those columns. You need to say what the type is. You need to say default values, whether it's required, things like that. Not going to be the case here in DynamoDB, and that's why you often hear DynamoDB and other NoSQL databases referred to as schemaless. And what that means is that schema is mostly not going to be enforced by the database itself. It's going to enforce that primary key attribute and value there, but it's not going to enforce sort of these other freeform attributes, and you can have those as you want. Now, we call it schemaless. It doesn't mean you don't have a schema. It's just it's in your application code. You're going to need to validate there and maintain your schema there rather than at that data layer. So those are the first four concepts I want to talk about. I want to talk a little bit more about primary key, because the primary key is very important when you're modeling with data. When you're modeling with DynamoDB, and we'll see a little bit more about that later on. But basically, all your access patterns are going to be driven based off that primary key, which is really important. So there are two types of primary key. The first one is called a simple primary key, which is made up of just a partition key. And then there's also a composite primary key, which is a partition key and a sort key. So let's look at some examples. Again, going back to that users table we had, this is an example of that simple primary key. The only element in that primary key is that partition key of username that's uniquely identifying that item. Now, if you're doing just like very simple data modeling that's just key value access, then you can do stuff with this simple primary key. But often if you have more complex access patterns where maybe you have one-to-many relationship, many-to-many relationships, things like that, then you'll use a composite primary key. So let's take a look at that here. Maybe now, each of our individual people, they work for a particular employer, right? So now our primary key has two elements. We're using that composite primary key. The first element, that partition key, is going to be employer, and the second element, that sort key, is going to be the username that we were using before. So you can see here, Alex DeBrie works for DeBrie LLC, and those other Amazon folks all work for Amazon Inc. One thing to notice there, you can see in the three that I've highlighted, they all have the same partition key. It's Amazon Inc., but they have different sort key values. And when I talk about that primary key being unique, if you're using a composite primary key, it's the combination of those two elements that need to be unique. So even though a couple items have the same partition key, they have a different sort key, so that's okay. You could have some with the same sort key as well, as long as they have a different partition key. That would be fine there. So now that we've got a little bit of that basic terminology, let's talk about SQL versus NoSQL, because I think before you really get going with DynamoDB, you have to know these differences, and I think it helps to understand some of like the underlying reasons and behind these differences as you understand what's going on here. So before we even get there, I want to talk about what I call DynamoDB's guiding principle, and this isn't sort of stated anywhere, but I think it underlies every decision they make. And basically they won't allow you to write operations that won't scale. So they're not going to allow you to do something at 100 users or 1,000 users. That's not going to work when you have 1 million users or 10 million users or 100 million users. And I think that's DynamoDB is different in that way from other databases. Like with a relational database, you can do some group bys or some counts, some aggregation type operations that when your database gets really big is going to slow down. Also, same thing with join operations. As your database gets bigger and bigger, that operation is going to slow down. Same thing even with MongoDB, which is another NoSQL option. I think they're more flexible about this to where they'll let you do things at small scale that won't work at large scale, and that includes some of the more flexible indexing operations that they have, as well as some of like the aggregation operations. They have this aggregation framework, allows you to do like basically distributed MapReduce, but it's really going to slow down if you have terabytes of data. So DynamoDB won't let you do that. this makes it feel rigid when you're learning something, when you're learning it for the first time, and maybe you only have 100 users in there, and you're like, why can't I just do this? And this is the underlying reason behind it. They don't want you to allow you to do something that won't scale. So that can feel restrictive, but it's really great because the one thing I like about it is once you design your data model and it works, it's going to work forever, and you don't have sort of this long-term drag of like having to rework your data model as you add, you know, an order of magnitude more users, things like that. So with that in mind, if we get into that SQL versus NoSQL, I think one of the big things is the importance of primary keys. So if you're coming from a relational database with SQL, you know, you can select any column you want, or you can filter off any column you want. You can filter on a column from a joined table or anything like that. Whereas in DynamoDB, you can't really do that. So if we go back to our table here with our composite primary key, you know, it's got that employer and the username. You can query off those primary key values. You can query off the employer. You can filter a little bit with the username as well, and do some flexible stuff there. But you can't query just off those free form attributes. So it's very easy to say, hey, give me all the users from Amazon Inc., right? Filter off that employer. But I can't say, hey, give me the person whose email is jeff@amazon.com. At least as how this is set up, that's not really going to allow you to do that. And we'll talk about some strategies on how to do that. But basically, those attributes you can't really query off. So that primary key is very important in how you model your data. The second thing that's a big difference for DynamoDB is there's no join operation. This kind of drives people crazy. They're like, how do you do this? Especially if I have you know, multiple different tables and all that. And I want to talk about why we don't have a join operation in DynamoDB. And you know, most people when they think about DynamoDB, they just think of it as this giant blob that stores a bunch of data there. I got this blue picture, right? And that can maybe have 10 terabytes of data in it, you know, and that's what you interface with it. But behind the scenes, it's actually split into these different storage partitions. And these partitions are maybe going to hold like 10 gigs of data for you. And then just as you add more data, they'll just give you more partitions. And you don't need to think about this when you're operating with DynamoDB, but I think understanding how this works can help your mental model. So they're going to split your data across partitions. And now when a request comes in, let's say we're doing a put item request, which is just going to write a new item into your DynamoDB table, and we want to add Andy Jassy here. So we've got that employer of Amazon Inc. We've got the username of Andy Jassy. What that DynamoDB front end is going to do is going to take that request, and it's going to run a function on that partition key, which in this case is employer. It's going to hash that value, and then it's going to look up in a hash map and just say, okay, where does this particular value belong? Which partition does it belong to? And in this case, maybe it belongs to partition 1, and it's going to go route to that partition and operate in that partition. And the great thing about this is you can add more partitions here. Like I've added this third partition here, and this scales really well. So if you have you know, 5 gig of data with a single partition, it's going to take just as long to figure out which partition it belongs to as when you have 10 terabytes of data and 10,000 partitions all behind the scenes. So this is basically an O1 lookup to look it up in a hash map to see where it belongs. So that makes it a very efficient operation, and you're narrowing your data space right away based on that partition key from 10 terabytes or terabyte or whatever it is down to, you know, 5 or 10 gigs, which makes it a lot more efficient. So that's how that partition helps. The problem is there then, this is basically why they don't allow joins, because they don't want to have some of your data on different partitions, or thinking about how to put data on the same partition to put it with the data it wants to be joined with. So instead, they just won't let you do joins at all, so you don't have sort of that cross-network request as part of a join operation. So that's basically what's underlying that. So those two things, I think, underlie a lot of the big difference between SQL and NoSQL, right? You have to use your primary keys. You can't just filter off anything, and then you don't have this join operation. So what are the implications of this? And I think there are 3 big implications. The first one is that you need to know your access patterns in advance before you design your table. So if you're working with a relational database, often you think about your application, you maybe build out an ERD, an entity relationship diagram, and you know, hey, I have customers, I have orders, I have order items, and you know the relationships between them. And once you have that ERD, then you basically just take that ERD and put it in your relational database. And you know, each entity gets a table in your database, and then if you have relationships, you join those tables, or you map those tables together using, you know, foreign keys. And then at query time, you use the join to sort of reassemble this data. And that gives you a very flexible access patterns where you model your data first and then you think about how to access it when you're doing relational data. But since you don't have the join, and since the primary key is very important in NoSQL, you sort of flip that on its head. So you still do your ERD diagram first, and then you think, hey, what are my access patterns? How am I going to be accessing this data? And then based on that, I'm going to design my table in a specific way to handle those specific access patterns. So just flips the order of that a little bit. Another implication of this is you're going to put all items in a single table, which feels really weird. This is called single table design. But imagine if you had, like I was saying, you're doing an e-commerce app and you have customers and you have orders and you have order items. They're all going to be in one table, all jumbled together. They're going to have different attributes and values there. And that feels really weird, but we'll look at a few examples of what that looks like. The last implication of this is you're going to have very generic attributes for the primary key. And I didn't introduce this up front because it's kind of jarring, but because you have all these different item types in a single table, they don't have sort of the same attributes for that primary key. It's not like if you have customer and order items that each one would have a username or an order ID or an item ID. So you have to have these more generic attributes that only really have meaning in your application. So that's a lot to throw at you. I'm gonna try and illustrate a little bit of this with an example. So here, just to set this up, let's imagine we're building a SaaS application, and we're gonna have two entities that we're sort of modeling in our SaaS application here. We have organizations, that's who actually signs up for our SaaS applications, creates an account, and then there are users within an organization. So I might sign up for the SaaS application, my organization, I have 5 seats, and I invite 5 people in my organization, right? So I have organizations and users. So let's map out the organizations first. And this is what it looks like here. I've got 2 companies here, Berkshire Hathaway and Facebook. A couple of things I want to point out because this can look like gobbledygook. But if you look at that primary key, you can see that the partition key is just called PK. It has a very generic name. It's not organization name or anything like that. It's just PK. Same with sort key. That's just going to be named SK. So very often your primary key is just going to be called PK and SK, and that's it. Then if we look at some of the values for those, you can see I have this prefix on the values there. I have ORG hash, and then I have the organization name, Berkshire, or ORG hash Facebook. And what I'm doing there is just sort of distinguishing what type of entity this is. This is an organization entity. Organizations are all going to have the same sort of pattern in my application. It's usually going to include some sort of prefix and then some sort of value from the item that I'm going to use to identify that item. So now I've got a couple organizations in there. Let's add some users into that organization, because remember, we're putting both organizations and users into the same table. I've done that here. So I still have those organization entities there. I've also highlighted in red the new user entities that I've added. A couple interesting things to note here. The user items share the same PK as their parent organization. So like Charlie Munger and Warren Buffett, they both work for Berkshire, so they have the same PK as that. They're going to be in the same item collection, which we'll cover here in a second. Then that sort key pattern is a little different. They're using user hash and then the username for that sort key value. Same thing with Facebook there and Sheryl Sandberg. Another thing to look at there, if you go look at the attributes over on the right-hand side, you can see that the attributes are different between the organization and the user. So an organization has the org name, the subscription level, whereas the user has, username and the role within that organization. All right, so I hope we're doing okay here. Again, there'll be plenty of time to ask questions because I know this is a lot. One concept I want to talk about is the concept of item collections and how those interact with queries. So when you're working with DynamoDB, most of the operations are going to work on a single specific item in that DynamoDB table. So it's like a key value store in some way, but it allows for more flexible things, as we'll see. But some of those operations that work on single items would be like get item, which will allow you to read an individual item, update item, which will allow you to update an existing item, or delete item, which will allow you to delete an item in your table. So again, you're working on a single specific item there. There is an operation called the query operation. And what this lets you do is read multiple items with the same partition key. And this is really powerful. It allows you to do some pretty interesting things. So if we go back here, this is our that employer and users table that we looked at before, I could go here and I could say, hey, give me all the people that work for Amazon Inc. And I would just use that query operation. I can operate on everyone that has that partition key of Amazon Inc. And that's going to get me everyone in there. Another thing I can do is I can have conditions on my sort key. So the second part of that primary key, where I could say, hey, give me all the people that work for Amazon whose username is between T and Z in the alphabet. And that's going to give me Jeff Bezos here and Werner Vogels, but it's not going to give me Jeff Barr because his username doesn't fall within there. So with that query, I need to do an exact match on that partition key, and then can also do conditions on that sort key. So query operation, really powerful. One term you want to know there is what we call an item collection. And that's going to be all the items that have the same partition key. And that's basically what that query is operating on, where those individual get item, update item, those are operating on single items, but a query is operating on an item collection. And the important thing here is this can include different types of items. Remember, we're putting a bunch of different items into the same table using single table design. And this is why we're doing this. Let's go back to that SaaS application there. If you see outlined in red there, I have the item collection as a whole for Berkshire. You can see at the top there outlined in sort of a dark blue is going to be that organization item. And then outlined in the green are those two user items. And this could be an access pattern where I say, hey, give me all the users for this organization, but maybe we want some information about that organization itself that we'd also enrich our users with. So this is sort of like a join operation in a relational database where you want to get some data from that organization item, but also all those user items. You can fetch all of those in a single request, that query operation, and then you can enrich those to handle some of that. So that's why item collections are really important. You're basically grouping together potentially different types of items to get in one request and pre-joining your data as you need it. So that's some of the basics. Let's walk through 3 common patterns I want to talk about to show how some of this stuff works, and then we'll open it up for questions. So first one I like to start with is how to handle one-to-many relationships. I think this is a really common one for a lot of folks, right? You have one-to-many relationships everywhere where you have some sort of parent entity and then some related child entities. And let's just walk through what that looks like. The interesting thing about DynamoDB, I guess, when you have a relational database, there's generally one way to do a one-to-many relationship. You have these 2 different tables. Your child table is going to point back to your parent table with some sort of foreign key reference, and then you join those together at read time to handle that. With DynamoDB, we don't have joins, so we have different strategies on how to handle one-to-many relationships. And I cover this in the book. There's also an open blog post if you want to go check that out. But basically, there are 5 different strategies on how to handle this depending on your specific needs. I would put these strategies into 2 different buckets. And the first bucket is what I call denormalization, right? So when you're learning relational databases, you learn a lot about normalization. Normalize your data. It's basically, I would say, basically don't repeat yourself for data is sort of how I boil it down into a sentence. But there's first normal form, second normal form, third normal form. You can go look all that up if you want to, but sometimes denormalization is a really good thing, especially in a NoSQL database. So let's look at how we handle that. Let's go back to this SaaS application. We have our 2 entities. Let's imagine we want to add a third entity here in another relationship, and we say, when you sign up, you can register different payment methods. So when Berkshire, the organization, signs up, they can add a credit card that's going to pay for it. But maybe if that one fails, they can add a backup credit card or a bank account or some other way, just so they don't get cut off if something happens. So this is a one-to-many relationship, right? An organization can have many payment methods. So the way we're going to handle that is what we have here, and I've just outlined it here. I've added this attribute called payment method, and it's on that organization entity itself. And what this is a I can't think of the word, complex, or it's like a document data type. It's not just going to be a scalar value like a string or a number, but it's actually going to be this map that has multiple values in it. So you can have maps and lists in your DynamoDB items here. And in this one, I just happen to have a map that has multiple different payment methods, and I'm handling that one-to-many relationship that way. Rather than splitting it out as different items, I'm just attaching it to that parent item itself. Now, you might want to know, like, when should I use this item? I think this is useful if 2 things are true. number one, you have a bounded number of related items that you have, because there's a 400 kilobyte limit on a single DynamoDB item. So if you could have potentially 1,000 or 1,000,000 related items, you wouldn't want to use this strategy, because you could exceed the amount of records on that particular, or the size of that particular item. So you wouldn't want to do that. You wouldn't want to use that for something like a customer and their orders, right? Because you don't want to limit someone making another order because they've already exceeded it, right? You want to still take that order. So that wouldn't be a good one there. But in this case, we're only going to have 2, maybe 3 payment methods on there. So it's pretty limited. We're fine. The second way I'd say, or the second thing you need to consider if you're using this sort of strategy is, do I ever need to fetch the child item or entity sort of separate from the parent entity? And that's not really the case here. We're not going to say, hey, I have this credit card, who does it belong to? That's usually not the case. We're usually going to say, hey, it's time for Berkshire to pay their bill. Go fetch that Berkshire entity, fetch their payment methods, and charge it. So we don't need to fetch that child entity outside the context of its parent entity. So that's why denormalization makes a lot of sense here. That's going to work in sort of a narrow subset of examples. So really a more common one, this second bucket of one-to-many relationships, is going to be using that item collection plus query strategy. And this is what we already saw here. If you're thinking about an organization and the users within an organization, that's a one-to-many relationship. An organization has multiple users that can perform actions on top of it. And that's where you're going to throw them all in the same item collection by giving them the same partition key as this. And that gets us to this view here, where if you make updates to that organization item, you change some things around it, it's in that same item collection as its users. So when you fetch all the users, you can use that organization item to enrich items about, or details about the user if you need to, before returning your request. So this is a second way to handle that one-to-many relationship. Oops, sorry, I'm gonna skip that one actually. Secondary index. Okay. Second pattern I want to talk about here is around uniqueness. So often with your data, you want to be unique on some sort of attribute, right? When a user signs up, you want to make sure no one already has this username. Or if you create an order, you want to make sure there's not an order ID or another order with the same order ID. You need some uniqueness across your database. So how do you handle uniqueness in DynamoDB? It must be built into your primary key. And this goes back to what we were talking about when you're talking about, all your access patterns must be on that primary key. It's because they can efficiently identify that item or number of items that are based on that primary key, rather than having to search the entire space. So it's got to be built into the primary key, whatever unique value you have. And then you use something called a condition expression to avoid an overwrite. So if you're using anything that writes data, like put item, update item, delete item, you can add a condition expression here to assert certain conditions about this item before you do any writes on it. So let's just look at an example here. Imagine we have some users in our database, in our application, and we want to make sure a username is unique across our entire space. So if someone signs up, we want to make sure they have a unique username. As you can see, we've built that username directly into that primary key. So in both the PK and the SK, we have the same pattern. It's user hash Alex DeBrie, user hash Alex DeBrie. And now when I'm writing, if someone tries to sign up with Alex DeBrie, I'm going to use that condition expression to make sure an item doesn't exist with that particular property. Now, just to take it a step further, sometimes you have multiple uniqueness requirements. You want something unique on 2 different elements. So going to our user example, maybe we want to make sure that no one has this username, but we also want to make sure that whatever email they signed up with, no one has signed up with this email, because we don't want someone signing up for 8 different accounts with the same email address. So we do this, right? So that's our requirement. What you might think to do is just jam the email into the primary key as well. So I'm just going to switch it here. And maybe you do something like this. And on the partition key, on that PK, you still have user hash Alex DeBrie. That's going to be the username. But then on that sort key, you have user hash, and then you have the email. So alex@debrie.com. And you're thinking, now I can assert uniqueness on both of these. That is not going to work, because what you're basically asserting there is that no one has that exact combination of values. No one is signing up with the username Alex DeBrie, with the email alex@debrie.com. But if they switched either one of those, then you'd allow duplicate emails or duplicate usernames, which you wouldn't want to do. So you can't do that there. What you have to do is a little bit weirder, actually. So what you have is you still have your username entities up top, those first three, those users. You can also add what I call just like a tracking entity and make these items down here where it's just the only thing they're doing is sort of asserting uniqueness on this particular email attribute. So when someone signs up, what you'll be doing is creating two items at the same time, wrapping it in a transaction. That first item is going to be that top item that identifies it by username and makes sure that username is unique and includes all the attributes about that user. Then you're also just making this tracking user email uniqueness item that is creating that, asserting that no one has signed up with that particular email address. If either one of those fails, it's going to roll back the entire transaction and reject it back at you. And then you can say, hey, someone with this username already exists, or someone with this email address already exists. So that's how you handle uniqueness in DynamoDB. I've got a blog post too on using transactions, and this is one of the examples I have. So go check that out also in the book as well. Yep, there you go. All right, last pattern I want to handle is I call reference counts, and this is good. This is kind of an extension of the relationship stuff. So one-to-many stuff also works for many-to-many relationships as well. So let's imagine Twitter. I hope you all are wasting a lot of time on Twitter. But here's what was the most retweeted tweet at one point. This was an Oscars tweet from Ellen DeGeneres a couple years ago. One thing to note down there, if you look at that, right, it says how many people have retweeted it and how many people have liked it. And this one has millions of retweets, millions of likes. That's a lot of stuff where if you were sort of calculating that every time someone pulled up this particular tweet, it would take a lot of compute and data read, right? Because you'd have to go and read through all the people that have retweeted that, 3 million items, and that would just take a long time to do that. So how can we do that more efficiently? And I guess going back to this, there are two things we want to do with this operation. Number one, we want to ensure that the related item doesn't exist. So if I see this tweet and I retweet it, we want to make sure that I haven't already retweeted it, right? I'm the related child item. I'm a retweet of this particular tweet. Want to make sure I haven't retweeted it already, because we don't want people just juicing stats, tweeting the same tweet multiple times. So first, we want to make sure that doesn't exist. But we also want to maintain a count of related items on the parent itself. Like that said, so on that particular tweet, I had 3.1 million retweets. Every time someone retweets, we just want to sort of increment that counter so that it's faster to look up every time we fetch that tweet. It'll be there rather than having to count all the related items there. So again, we're going to use a transaction in this case, and we'll be doing two things in that transaction. First of all, creating that related item, creating that item indicating that I have retweeted this particular tweet. And then we also, second, want to increase that counter on the parent. So on that parent tweet, there'd be a property like retweet count and like count. And when I retweet it, you can actually just in that operation, you don't even have to know the current value. You can just say, hey, increment this by 1 or whatever you want to do. So it increments that. You wrap that in transaction. If either one of those writes fails, it's going to roll back the entire transaction. Neither one of them will happen, and you can reject back at the user. And that makes sure you have the proper sort of data consistency that you want there. All right, that's what I have. So just a summary in terms of what we covered. First we went through terms and concepts on DynamoDB, just walk through those 4 common terms, a little bit about primary keys and what they mean. Then we got into SQL versus NoSQL. We talked about some of those things where DynamoDB is different. So important to use that primary key properly, because that's going to drive your data access, and also you don't have joins. What are the implications of that? How do you do data access? Or how do you design your table? How do you put all the entities in a single table and things like that? We talked about this concept of item collections and queries and how you can use that query to enable more powerful things than just a key value store, which I think is great. And then we walked through the 3 common patterns, which are one-to-many relationships, uniqueness requirements, and then also reference counts as well. So yeah, I'm open for questions. Here are places you can find me on Twitter there, Alex B. DeBrie. I also blog at alexdebrie.com, and then the book and the guide itself as well. Whew, okay, deep breath. Yeah, I don't know how we want to do questions here, but yeah, just shout them out, I guess.
Okay, that was awesome, Alex. Thanks so much for that. Now we've disabled event mode. So essentially, if people want to, we'll either look through the chat and read out the questions, or feel free to take yourself off and mute and ask them yourself, or come on video or whatever. So the first question that's down there is, what would be a use case to use a local secondary index?
Yep, good question. So we didn't talk about secondary indexes, but I can just give a little background before I answer that one. So I talked about how primary key is very important for your access patterns, but it can be kind of limiting, right? Because maybe you do have multiple access patterns. To go back to that user example, what if we do want to look up users by their email address? How do we handle that? You can add something called a secondary index on your table, where you just say, hey, create this index. Here are the attributes in my index. And now if you write items into your base table that have those attributes, they're going to get copied over into the secondary index. And it's basically like a copy of your table, and you can perform the read-based operations on that secondary index. So you can get find users by that email address and enable these additional access patterns. So the great thing about that is Dynamo is going to handle that replication for you. Now, there are two types of secondary indexes: global secondary indexes and local secondary indexes. I almost always recommend using global, just because they're more flexible and easier to use generally, and they don't have quite as many limitations. But local secondary indexes you can use as well. The only time I would recommend using a local secondary index is if you require consistent reads on that secondary index, because you cannot get strongly consistent reads on your global secondary index. What they're going to do is sort of replicate that out, and you get eventually consistent reads. Usually there's 200 millisecond delay from writing it from into your main table to when it gets replicated out in your secondary index. Usually that's okay, but if you need a strongly consistent read from that secondary index, you'll need to use a local secondary index. It has some limitations on sort of what you can use there. So it has to have the same partition key as your base table, which is pretty limiting for most folks and most access patterns. It also adds a few other limitations, and it's very flexible. You have to create it when your table is created. You can't sort of add it or delete it later on. So I would lean towards GSIs unless you need that strong consistency.
Well, so the next question was, how does the efficiency of DynamoDB streams work with single table design? I think giving a scenario around sending a push notification to a phone when a small subset of items change. Yep. Like I say, there are alternatives like using an event-driven approach, using Event Bridge and Lambda and so on.
Yep, good question. So again, additional background we didn't talk about there, but DynamoDB streams, you can enable this on your DynamoDB table. And basically every time there's a write operation into your table, if you insert a new item, if you update an existing item, if you delete an item, they'll drop an item into this stream, just a record of this event happening, and then you can consume that stream. So if you're familiar with things like Kafka or Kinesis, it's going to be a stream like that. You just get this stream of records, basically saying everything that's changed in your DynamoDB table. Now, the question is, if I'm doing single table design, I have 15 different entities in here, and maybe only one entity is what I want to actually operate on. Is it still efficient to use streams rather than use something like Event Bridge or something like that directly from my Lambda first up? I would say it depends a little bit. It's hard to answer completely in the abstract, but I think I would still use Dynamo in most cases. I used to sort of argue that we should have better filtering on Dynamo streams out of the box, but the thing is, it's pretty quick and easy in your Lambda function to filter out what you want and drop it and end your request early as you're processing that stream, and it really doesn't cost you that much. So I think the hassle of adding that feature or configuring that feature really isn't worth that much, to where if you're getting the stream and there are 10 different entities and you only care about one of them, all you do right away is you get a stream of 10 events and you say, okay, all of these are the entity I don't care about, so therefore I'm just going to bail and end early in my Lambda function. And I'm basically not charged anything. Like a Lambda function that just does that is probably going to be less than 100 milliseconds, and it's not going to require very much memory. So it's going to be pretty easy to do. So I think the savings aren't worth that much, unless the volume is just so huge. Like if it really is a needle in a haystack that you're finding there, and you had a really big table, then it might be worth doing a different pattern like Event Bridge or something like that. But in most cases, I would say just have some filtering in your DynamoDB stream logic, and it won't really cost you too much money. Cool. But good question.
The next question, what's the advantage of using provisioned capacity over on-demand? Is it just the cost?
Yeah, this is a great one. So I sort of mentioned this at the very beginning, but there are two billing modes you can do with DynamoDB. One is you pay, you provision up front and you say, I want this many read capacity units and this many write capacity units. And if you ever exceed that, you're going to get throttled. Like they'll give you a little bit of burst over it, but if you're consistently exceeding it, your writes will just fail at some point. They also have a newer billing mode, I think is now a year and a half old, maybe 2.5 years old. It's called On Demand, where you don't have to provision any of that up front. You just say, hey, when a read or write comes in, you handle it and you charge me for it. And then you don't have to worry about capacity planning. Now, the difference is the on-demand price is almost 7 times more expensive as the provision price, but that's assuming that you're completely using your provision capacity, which is really, really hard to do even at peak times. And really it's likely, if you have some sort of peak in traffic, maybe at peak you're getting 80% usage just because you want some buffer. But then at off-peak hours, maybe you're down at 10 or 15% capacity. I think for a lot of people, unless you have pretty predictable traffic patterns and you're actually doing some work on it, I think they're actually going to save money doing on-demand capacity, just because it's so hard to get pretty good usage there. And really, you only need you need to be getting better than 25, 30% usage, but a lot of people aren't doing that. And if you think also about the time that it's saving you in terms of capacity planning, I recommend on-demand billing for almost everyone. And Jared Short, a friend of mine, he always says, use on-demand until it hurts. If your DynamoDB bill is like $100 a month or even less than $1,000 a month, just do on-demand and don't worry about it. And if it starts to become a meaningful part of the bill where it's costing you a lot of money, then take some time. You've also got 6 months of history that you can look at and say, okay, what are my traffic patterns? And maybe you can do auto scaling with provision capacity to save some money. But if this is a brand new application and you have no idea, you're just guessing, like do on-demand, or else you're just gonna, I think, spend a lot of time without saving much money usually.
So the next question, how much more performant is primary key access on the main table versus GSI?
They should be pretty similar. You're going to have, with that GSI, you're going to have the eventual consistency that I talked about. So maybe, there's going to be a delay of a couple hundred milliseconds. That's also true on primary key access with your main table, unless you opt into strong consistency. So you can choose on your primary key to say, hey, I want a strong and consistent read, but by default, it's going to be an eventually consistent read, which is going to cost you half as much in your read capacity, which is fine for most people. But other than that, you should see pretty comparable access times, doing a query on your primary key versus on your GSI, other than that consistency stuff.
And then the final one that's up there at the moment, do you tend to always use the sort key of the main table as the partition key for a global secondary index?
No, I don't. And actually, I have a few examples out there from talks and things like that where I might reuse some keys from my primary key in my secondary index. I would not recommend doing that. I would actually recommend creating entirely separate attributes altogether. And the reason being, if you have 5 to 10 different entities in there, they're going to have all these different access patterns, and basically you're using these generic key names, key attributes in your primary key, in your secondary indexes, very generic ones to handle different access patterns for different types of entities. And I think it's really hard just to like keep your brain in order where you're like, okay, the PK from my main table, or the SK from my main table is going to be PK in my first GSI, and that's going to be true for, like, that works for this entity, but it doesn't work for this entity. And I think it's just hard to keep track of. So I just recommend I call them indexing attributes and application attributes. And application attributes are everything that's actually meaningful in your application. That's going to be the username, the first name, the last name, the email, all that stuff. Then indexing attributes are only attributes that you put on your items to index them properly in DynamoDB, whether that's with your primary key, whether that's with your secondary indexes or anything like that, whether that's with TTL. That's the only reason they're there, is for that. And I just separate them and make sure they're completely separate and they're only used for one purpose.
Okay, now there's a few more coming in. So what we'll probably do is try and do another like 5 minutes of some of your questions.
Sure thing.
Any guidance around how to deal with sorting in DynamoDB?
Yep. So I have a whole chapter on this in the book with like a bunch of different strategies. So check that out. But basically, sorting is going to be within a within an item collection, so all items with the same partition key are going to be sorted basically in ASCII or UTF-8 code bytes according to the sort key. So you can think of the sort key. I guess what I like to tell people is imagine a dictionary, and if you have a composite primary key, all the items with the same partition key are going to be like a dictionary, and they're going to be sorted according to that sort key value. And you want to sort them in the relevant way that you can get a range of values, just like you would in a dictionary. If you wanted to go to a dictionary and get everything from dog to elephant, you could do that. You get one contiguous block of items there, and that's going to be exactly what you can do in DynamoDB. So it's going to be ordered in UTF code bytes. A couple things you need to know there, like numbers come first, symbols are also relevant. Also, all uppercase letters come before all lowercase letters, so make sure you know that. So one thing I would say is you're often going to want to normalize your sort of string values, either be all uppercase or all lowercase if you're doing something like uniqueness or sorting that way, because that's going to become relevant. You don't want to have weird things there. The other thing I would say is there are a couple different types of identifiers. I use one called the KSUID, but there's also one called the GLID, which basically gives you a unique ID that is also sortable based on the timestamp of when it was created. And that turns out to be useful in a lot of different places, because in a relational database, you have like this auto-generating sequence number that can be useful for things. But in a distributed database like DynamoDB, there's not something like that. So you have to create your own unique identifiers like a UUID. But often you want sorting based on creation time, if it's orders for a particular customer or something like that, or comments on a post. You want some sort of sorting while also having an ID. So there are these couple different algorithms and mechanisms, KSUID, GLID, that I would look into if you need that combination of unique identifier plus chronologically sortable.
Cool. And then another one's come in, which is talking about, obviously you mentioned at the beginning about understanding your access patterns up front, but if your access patterns change, is there any guidance around refactoring data?
Yep, sure thing. So I have a post on this too, and it's covered in the book. So check that out. But one thing, it depends on like how much it's changing. Like if your data is completely changing and like you're like, we screwed it up, we need to do it. Well, now you're going to need to do like an ETL process, just like you would in a relational database or anything else. But if it's more sort of additive, like you're adding new entities in, or you have new ways to access old data, things like that, I find it's pretty straightforward in most cases, and I lay out a couple different buckets in the book. But it depends on what you're doing. If you're just adding an attribute to an item, that wasn't there before, you often don't need to do anything in DynamoDB. That's just a code issue, right? Because you're not sort of declaring your attributes in DynamoDB schema. If you're adding a new entity to your table, often you can do that just in your code, not in DynamoDB, because you're not doing anything there. Now, if you need to have existing data that you're accessing a new way, or you need to sort of join two items together into a new secondary index, that's a little different. What you usually do there is run like an in-place ETL process where you scan your entire table. If you find an item that needs updating, then you say, okay, add these new attributes, which are going to be used in this secondary index. Go through that whole thing, and then once that's done, you create your new secondary index, and you're good to go. And it's actually pretty formulaic in how it works. You scan, you identify the items that you need to manipulate, and then you update those items accordingly, and you're good to go. And it feels scary because it's different than a relational database where you maybe just add an index or something like that. But once you've done it 2 or 3 times, I think it really is pretty straightforward.
Cool. Now, I'm conscious that we may end up running out of time for some of these questions. What I might try and do is take an extract of the chat and just sort of put them out on Twitter.
And really, I have as much time as people want. So if you want to hang out at the end, yeah.
So the next question was, do you have any advice for using a single DynamoDB table with Saga? So step functions for complex transactions with rollback, and then touching around things like DynamoDB Transactions.
Yeah, I don't have any specific advice there. I would say lean on transactions where you can. I think they're a really great thing that got rid of a lot of these Saga things, especially where if you can do it all if you have all the data at the same time and can handle that in one operation, I think transactions make that life a lot easier for you. If it's something where it's a more complex Saga where you're waiting from data at different times and then needing to roll back based on that, it's tricky. It's really based on your access pattern. You're probably going to need to write a lot of that stuff yourself and work through that different business logic. But I would say lean on transactions where you can, because they really simplify a lot of stuff that used to be pretty difficult or that required multiple requests.
Yeah. There's a question then around, are there any methods for advanced data analytics, such as like live dashboards of orders on data that's held within DynamoDB?
Yeah, so that's a good question. I would say generally no. Like DynamoDB is built for OLTP, which is like individual transactions on like 1 or 2 or 3 records at a time. Lots of fast transactions rather than OLAP, which where you're saying, hey, how many orders did I have last week, or like what was my growth rate over the last month, or things like that. So generally no. But I've also got an insert in like the plus and the premium package about how to do analytics in DynamoDB, because you often need it, and it really depends on your thing. If it's questions that in advance, then you can actually just build that into your table like you would anything else, and just count that as another access pattern, even if it's just for internal use. So every time, if you want to have a running count of the number of orders you have this month, or the number of orders by region, things like that, whenever you create a new order, you can also just increment the relevant item or things like that to handle that. That works in pretty limited cases, because often with analytics, you want more ad hoc questions, right? Where you don't know the questions in advance, you want to explore your data a little bit. So then you need to get your data out of DynamoDB and into something that works. If you're using Amazon Redshift already, it's very easy to run copy, basically export your entire data from DynamoDB into Redshift. You can just run a command in Redshift, and just like you would copy data from S3 into Redshift, you can copy data from DynamoDB into Redshift. So I like that if you're already using Redshift. If you're not, Redshift's kind of expensive, so you might not choose to use it for this. So then I see people export it to S3 and use something like Athena. And then the last option would be you can use DynamoDB streams, which we talked about earlier. And every time you get an item, you can go update some other type of database. That's often pretty tricky, but can work if you really need more like real-time type data.
Well, then the final question, what's the final question? If I suddenly do a lot of writes into an on-demand table, so this is talking about 5,000 batch writes, I get a lot of unprocessed items back. Do you need to warm up on-demand tables for it to take a surge in writes?
Yep, so that's a good point. If you have a really large spike in on-demand, if you're doing on-demand and you have a very fast spike, you're going from 0 to 1,000 write units per second, you will get throttled a bit there, and they just can't handle enormous spikes up. Although, man, I haven't done extensive testing on this, but I think Jan Trey did some good stuff on this. If you check him out, he's the Burning Monk on Twitter. I'm pretty sure he did it, maybe someone else. But basically, I think let's see, your sort of max throttled amount is whatever the highest amount you've either already been to or that you were provisioned to at all. So I think you can like provision your table at 10,000 read and write requests. And then 2 minutes later, switch it to on demand, and it basically gives you that capacity that you can scale up to right away. I'm not sure. I would do some testing around that, but I've heard some stuff around that. And again, that's only for very fast scale ups. You'll have like a 5-minute delay, I think, in sort of getting some of that throughput.
And then the final question at the moment is, do you tend to wrap up your attributes, your entities, into an iData object for item attributes and a pData object for attributes projected into indexes? This comes from a Rick Houlihan tweet, or is this unnecessarily complicated? Does it complicate things?
Yeah, that's a good question. So just to clarify a little bit on this, I mentioned like those other attributes, especially what I call application attributes. You can't really query off those in DynamoDB. So what some people do is just collapse those into like either a JSON string or a map attribute, just a single attribute with all the application attributes, and the only other attributes are ones that are actually used in your primary key or secondary indexes, things like that. Rick has advocated that. Rick Houlihan, he works for AWS, and he's really the DynamoDB wizard that you should check out. I think that's something you can do for sure. It sort of depends on your use case. For me, I mostly talk with startups and other people where DynamoDB is not a huge part of their bill and they don't need to optimize that way. And I think it's fine just to do it the sort of normal way where each attribute is, or each property you have is a separate attribute. This can work, especially if you're have some large attributes that you're not projecting into every single index. So when you create these secondary indexes, you can choose which attributes go into those indexes. If you have some large attributes, maybe a large binary blob or a huge document of some type that you only want on your primary key, your main index, but not your secondary indexes to save on storage and to save on read and write units, you can do some strategies like this. I would say, in general, like, know that you have a problem first before you go out and try and solve that one. I think this is absolutely a problem for people that have really large tables or weirdly shaped data. But I would say it's not something I recommend as like your first step, I think.
Cool. So that's the end of the questions. There was a lot of chat at the beginning about your book, and in particular in terms of talking about different versions. So you're able to just give a very brief in terms of what the different versions are. Then obviously, from my perspective, I've got a copy. I think it's an absolutely fantastic book. There are a number of people throughout who are talking about it.
Yep, sure thing. So there are 3 versions of the book. They're all electronic. So even though this image I have here looks, I don't know if you can still see my screen, but I had like a fake looking book on there. It's not a real book. You're not going to get a physical book. The basic package is going to include the book, which is going to be 450 pages. It includes a lot of background and sort of introductory stuff. It includes a lot on what I call strategies, which would be like one-to-many relationships, many-to-many relationships, sorting, filtering, migrations, all that stuff. And then it has 5 full walkthrough examples that show you, hey, here's an example. And like the one I had the most fun with is GitHub. So we actually like recreate all of GitHub's metadata backend, like users and organizations and repos and stars and issues and pull requests and all that stuff. And it was a lot of fun to do that one. So that's all included in the base package of the book. It also includes some like a PDF of some worksheets that you can print out that just have like sort of summaries of the chapters or of like Python or JavaScript APIs if you want to print those out and have those handy for you. The second package, the Plus package, includes all that original stuff, but also a couple additional inserts. I mentioned the analytics insert, and that's like I think it's 60 or 80 pages of how you handle analytics. We talked about those analytics things. There are a couple different strategies. Here's sort of when you might want to do one versus the other. So we do that with analytics. There's also another insert about operations. So it's infrastructure as code, it's IAM permissions, it's billing, it's a couple other things like, backups and restores, things like that. Just some other operational stuff around DynamoDB, because the main book itself is mostly data modeling. It has that. It also has full code examples for all 5 of the examples in the book. So you get JavaScript examples of all 5 examples there. So you can sort of see what the code looks like. You can actually deploy it using Lambda and API Gateway and DynamoDB and interact with that as you want to. Finally, last package has all that previous stuff plus video recordings of all the chapters in the book. So if you didn't get enough of me talking today, you can get 4 hours of me talking on there as well.
Excellent. So yeah, thank you so much, Alex. Make sure everyone who can go and check out the guy, go and check out the book, follow Alex on Twitter. Thanks so much for coming along, and keep safe, everyone. Keep an eye on the our Twitter feed and meetup, and we'll be announcing our next talk shortly. But thanks.
Okay. One more note here. I'll create a code. I just did it South Wales, so in all caps South Wales. I'll give a discount. I haven't set it up yet, so give it 10 minutes or so, but use that code. If you have any problems, email me, ping me on Twitter, whatever it is. I'm happy to give different discounts there. So
brilliant. Thank you very much. Bye.
Thank you all.
Thank you very much, everyone. We'll see you all soon. Bye.